Good afternoon, students. Today I am going to present the video session of 3D printing. I am Dr. P.K.MANIKANDAPIRAPU. I have pursued in my BE in Engineering College in 2005. I did my post-graduation in PhD College of Technology, Coimbatore. I have studied in ME Energy Engineering and my PhD work in Visvesvaraya Technological University, Karnataka, Belgaum. In that I have completed my PhD in 2018, and I am having 15 years experience in teaching. So now I am working as an associate professor in PSN College of Engineering Technology in this Department of Mechanical and Automation Engineering, PSN College of Technology, TIRUNELVELI. Today I am going to start my video session of 3D printing. In this 3D printing, we have to start the introductions. Manufacturing is a process in which raw materials are transformed into finished goods. Additive manufacturing is a technology that can make anything, eliminate many constraints imposed by conventional manufacturing, lead to more market opportunities. It's created a lot of opportunities, plenty of opportunities. One of the important and very wide and emerging and excellent technology is additive manufacturing as a 3D printing technology. Increased applications such as 3D faxing and sensors and scan the 3D object in a particular cross sections and sends out the digital image layer, and then the recipient receives the later image using the AM machines to fabricate 3D objects. What is additive manufacturing? The process of joining materials to make objects from three-dimensional model data, usually layer by layer manufacturing, commonly known as 3D printing technology. The manufacturing components with virtually no geometric limitations or tools. AM uses only an additive process. Design for manufacturing or to manufacturing for design. We can able to distinguish from traditional to subtractive machining technology, not a removing or metal removing process. We are adding layer by layer. We are making our required things in adding layer by layer process. So this is an adding process, not removing process. This is our path. First we have to complete our 3D geometry in CAD model. Then we have to convert to .stl file we have to make. Then slicing technology or slice layers or tool paths as a sliced layers, and 3D printer machines we have to make the object in 3D printing machines. And this principle is system starts by applying a thin layer of powder material to building a platform. We have used our laser beams and fused the powders in laser fusion melting, fusor deposition modeling, and exactly points of data defines by the geometry by the computer generated by component design data. Performance is the lower and another layer of powder is applied. Once again the material is fused so as to bond within a layer below predefined points. So CAD model, STL file, slice layer, 3D printing machines and 3D object. This is our final starting steps to end of the product. So we have to make first CAD in this diagram. We have to make CAD model. Then you have to make this exit file and import or export to the technology into .stl file. Then enter to slicing layer and tool path and giving to the machine to make them to convert into G codes and M codes, and then finally make a final product. In this advantages and disadvantages of 3D printing: freedom of design, complexity for free, potential elimination of tooling, lightweight design, eliminations of production steps. Disadvantages: slow build rates, high production cost, considerable efforts required for application of design, discontinuous production process, limited component size. Applications used in diverse array of industries including automotive industries and aerospace industries and biomedical industries and consumer goods and many others. These are the technology involved in additive manufacturing process classified into 7 categories. This is the technology involved VAT photopolymerization techniques. First one is VAT photopolymerization techniques or stereolithography. This is one of the technology. And then next process is material jetting. Material jet in the form of liquids. Then they would send through the machine and through the tap, and we can get the form in binder jetting machines, material extrusion process, powder bed fusions, seed laminations, and direct energy deposit process. This is the totally 7 process. First one is bed photopolymerizations, and second one is material jetting techniques, and third one is binder jetting, and fourth one is material extrusions, and fifth one is powder bed fusions, and sixth one is seed laminations, and seventh one is direct energy deposition process. In this, first one is VAT photopolymerization or stereolithography. In this, they have included the laser beams. It's a pot pattern. In this stereolithography, elevator platform also decreasing the elevator platforms. Here in this ground level, like water column, like in this we have fill this resins also filled and coated with the laser techniques, and elevator will be down in the descents and immersed in a chemical path, and stereolithography requires supporting structures and complete this 3D printing process. This is one of the stereolithography techniques. Next process is material jetting. What is meaning material jetting? Is the material jetting in this drop forms, drop on demand methods. Here printing head will be used, is positioned in the above platform. Material is deposited from a nozzle which moves horizontally across the bit platforms. The material is curing and hardening. When you have to paint some material, you have to cool, then you have to dry, then make them to get a proper process. So proper curing and dry, you have to dry the layer by layers, then you will get the output. So drop it of materials, solidifications and make up the first layers, and the platform descents. Good accuracy and surface finish occur in this material jetting techniques. Next techniques is binder jetting. In this binder jetting techniques, we have used glue or binder. The glue or binder is jetted from an inkjet style print head. Roller spreads a new layer of powder on top of the previous layers. The subsequent layers is then printed and stitched to the previous layers by the jetted binders. The remaining loose powder in the bed supports overhanging structures. So these are the techniques. Binder is jetted in the inkjet spiral head. Roller spreads a new layer of powder. The subsequent layer is printed and the layer by layer of previous layers. The remaining loose powders in this bed supporting overhanging structures will create. And material extrusion techniques is the next techniques is another name as FDM, fuse deposition modeling or material extrusion techniques. Material is turned through a nozzle where it's heated and then depositing layer by layer. Your first layer is built as a nozzle, deposits the material where occurred onto the cross-sectional area. The following layers are added on the top of previous layers. Layers are fused together upon the depositions as the material is in the melted stage. So, this is the material spools, this is the heating element, this is the nozzle, and this is the object drawn by wire. This is the platform success. In binder jetting, the liquid adhesive supply, this is the inkjet printer head and build parts and powder bed and build platforms. This is powder supply and this is leveling rollers. And previously what we have shown in material jetting, UV QD lamp, leveling blade and elevators, build platforms and build substrates, part substrates and build materials and support structures. And previously in SLA we have seen lasers, OE platforms, RJQ, photoresins and VAT techniques. These are the things involved in these various diagrams, how the VAT photopolymerization is constructed and material jetting is constructed and binding jetting machine will be constructed, and we have seen in the diagram in material extrusion techniques are involved in fused deposition modeling. They have explained. Next one is powder bed fusion techniques. Powder bed fusion techniques. In this powder bed fusion techniques, we have three things involved. One is selective laser sintering. Selective laser sintering, SLS, and next one is SLM, selective laser melting. Selective laser melting, and third one is electron beam melting. Three things are involved. One is selective laser sintering, and second one is selective laser melting, and third one is electron beam melting. These are three powder bed fusion techniques is involved. In this process, we have used these lasers and this powder bed and build platforms. New powder stocks will become as a powder rollers came again through the process. In this process, a layer is typically 0.1 mm thick of material is spread over the build platforms. The SLS machines, what is meaning SLS machines? Selective laser sintering. The selective laser sintering machines breeds the bulk powder material in the powder bed and lasers fuses the first layer. A new layer of powder is spread again in the process, and further layers or cross sections are fused, then ordered. The process repeats until the entire model is created. This is the powder bed fusion techniques. And next process is sheet laminations. Material sheets are used. The laser beam cuts the contour of each layer. The glue activated by hot rollers. You can see in this diagram. It's a build platforms and used material spool, and the laser used and motorized mirrors and cross hatch materials and material spools. This is the involved, and each layer by layer is added. The material is positioned in the place of the cutting bed. The material is mounted in a place over the previous layer using the adhesives, and the required shapes in this then cut the layer by layer by lasers or knife. The next layer is added. Next we are going to see these techniques, the directed energy deposition process. In this diagrams we have used electron beam and material wire supplies and metal wires and build platform and object and electron beams. It consists of nozzles mounted on a multi-axis arm. Nozzles can move in multiple directions, and material is melted upon the depositions with the lasers or electron beams we have used. A process A4 or 5 axis arm with nozzles moves around a fixed object. Material is deposited from a nozzle onto existing surface of object. Material is either provided in a wire or powder form. Material is melted using a layer, electron beam or plasma arc upon the deposits. The further material is added a layer by layer and solidifies and creating a Pre-pairing of a new materials feature on the existing object, like layer by layer, new material will be constructed in the direct energy deposition techniques. What is the present conditions and trends technology in this stereolithography (STL)? First is decomposed into a series 2D, then finally thick cross sections, which are then fed into AM machines, usually directed and indirectly to produce prototype parts, reduce manufacturing and product cost. University they have collaborated with technology transfers and AM technology. For that, additive manufacturing technology, reduce time to market, product quality, product performance and cost. Future aspects in the technology and innovations. This is that industrial revolutions, the cost effectiveness, mass customization of complex products, reduced material waste and energy consumption process, adopt a new product designs without adding expenses. In the biomedical fields, AM can be used to fabricate the tissue scaffolds. AM can be used to fabricate tissue scaffolds that are biocompatible and biodegradable and bioabsorbable. Additive manufacturing process can be used to fabricate tissue scaffolds that are biocompatible, biodegradable and bioabsorbable. You use this technique STEMS educations. However, 3D printing causes creating an opportunity of AM enabled and laboratory primary, secondary and post-secondary schools across the nations. In this additive manufacturing technology, by using ASTMs, AM is the process of making 3D objects from computer model data by joining material by layer under computer control using by 3D printers. This is subtractive manufacturing. This is additive manufacturing. What is the basic principles involved? First one is modeling, and first category is modeling, and second category is printing, and third category is finishing the component. First CAD model to finishing is 3D object. First 3D CAD model, STL file, slicing software, slices and tool path, and 3D printer machines, and finally you have to get extract the 3D objects. This is the topics: modeling, printing, and finishing. Modeling using CAD and SolidWorks software to make of CAD packages to make a component in software. Then we have to send the file into 3D scanners or camera and photographic softwares, and conversion into STL files. 3D models are converted into software readable format. Then printing technology, processing of STL file into slicer, slicing model into a series of thin film depending on the resolutions up to 16 micrometers, produce a G-code files, layer by layer construction is constructed, and finishing is removing manufacturing parts from the machines, removal of extra material supports, minor cleaning and surface treatments and painting if required. This is the classification of total additive manufacturing or 3D printing technology. In this category wise, material extrusions, powder bed fusion techniques, PAT photo polymerizations, and material jetting and binder jetting, and sheet laminations and direct energy deposition process. In these techniques, in material extrusions, we used FDM, fused deposition modeling, and contour crafting models. In powder bed fusion techniques, you have used SLS, DMLS, SLM, EBM. SLS means selective laser sintering. DMLS, direct metal laser sintering. Direct metal laser sintering. SLM, selective laser melting. SLS means selective laser sintering. DMLS means direct metal laser sintering. SLM, selective laser melting. EBM, electron beam melting. These are the techniques involved in this 3D printing or AM technology. And SLA, stereolithography. And we have used polyjet or inkjet printing. And in indirect inkjet printing, we have used in binder jetting techniques. And sheet laminations, we have used laminated object manufacturing, LOM, laminated object manufacturing. And we have used direct energy deposition process, laser engineering object shaping lens, laser engineered net shaping lens, electron beam welding. These are technology we have used. In printed ink, we have used the technology used thermoplastics technology and ceramic slurries and metal plastics, metal paste, ceramic slurry, thermoplastics we have used. Here SLS, DMLS, SLM, EBM we have used polyamides or polymers, atomized model powders, stainless steels, cobalt, chromium, titanium, Ti6Al 4V, titanium Ti6Al 4V, and ceramic powders we have used. And PAT photopolymerization techniques, photopolymers and ceramics, alumina, zirconia, PZT, and material jetting, photopolymers and wax, binder jetting, polymer powder, plaster, resins, ceramic powders and metal powders we have used, sheet laminations, plastic film, metallic sheets and ceramic tapes, direct energy depositions, molten metal powder. These are things we have used. In this power source, thermal energy, high powdered laser beam. These are things we have involved. Electron beams we have used. Here, ultraviolet lasers and thermal energy and photo caving process, and thermal energy. Here, laser beam and direct energy deposition process, laser beam used. This is a plus and minus of each expensive process, and this will involve in these various technologies. Next one is comparative statements of a additive manufacturing process, design flexibility and cost of geometry, dimension accuracy, no need of assembling, time and cost efficient production is very toughest part we can able to make in this additive manufacturing technology. Very difficult, very tough, very making is a very tedious. That things should be complete in additive manufacturing technology. This is very easy. These are the building capabilities of AM, layer by layer, pulmonary series, locomotive mechanisms, lithium ion battery, printed prosthetic limb, artificial air, printed PCBs, printed turbine boards. This is valves first 3D printed jet engines. That is the things called jet engines. Valves first 3D printed jet engine. Additive manufacturing process. The process of designing to make objects from 3D models, usually layer by layer, which are 3D printed technology. Subtractive manufacturing uses the techniques such as milling, cutting, turning to create an object from single piece of materials. Types of materials should be used: plastics, polylactic acid filaments, most commonly used materials in for 3D printings. Metals, we have used brass, bronze, titanium alloys, stainless steels, others wood, carbon fibers, bio and organic materials. Types of additive manufacturing. First one is fused deposition modeling, resin stereolithography, SLM, EBM, EBAM, binder jet, LOM. These are techniques already we have seen. And slicing software is G code. Slicing software takes a CAD model and converts it to G code. G code is a programming language to operate the machines. Code is helps to start up and set up and heat, temperature and movements. And converting slicing software will allow you to variety of settings depending on the machines. Most slicing software will not show the G code because CLMs of the programs, and these are the things involved in additive manufacturing technology. Support structures and unsupported materials, supporting materials, high density materials, how will be used, and bridged surface and control support placements and types of support materials involved in this process. And additive manufacturing is with respect to plastic fused deposition modeling involved. How the techniques in next technique is resin printing. How the continuous liquid interface production will be involved, additive manufacturing, electron beam melting, how we innovated the things involved, how the beam involved and how scatter and complete the process and completed by using electron beam melting. The layer by layer is shown in this figure. And additive manufacturing techniques, electron beams, electron beam dead, electron beam pre-deposit and substage, wire feeder, re-solved array, and additive binder jet printing machines, how will involve through various process and technology, process and advantages and disadvantages and post-process involved in these things. Next we are going to see about the reverse engineering. Reverse engineering is a mechanical engineering, involves analyzing and reproducing existing products to understanding the design and functions. See the requirements, architectures, requirements are recovery, code, new requirements, design and implementations. Reverse engineering, this is called forward engineering, and reverse engineering means implementations, design and requirements to what are the requirements involved. These are things reverse engineering. Next we are going to see this real reverse engineering, requirements, design, implementations, architectures, code, design, recovery and completed by requirements, forward and reverse. These are the things involved in the 3D printing. And this is a finned blade, aerofoil blade is manufacturing by digital production plan of new turbine blade is created on computers. First, what is the setup will be involved? A layer of powder of high performing super alloy is applied. Then fiber laser beam fuses the powder, thereby creating in the first layer of the turbine blade. The platform lowers by few micrometers, lowering the component being produced. Then it will come to layer by layer. New coats of the polycrystalline nickel superalloys are applied and fused. Then it will come into picture. The laser traces the outline of the digital production of plan on every coat. Finally, at the end, heat resistant turbine board emerges out the powdered superalloy. And additive manufacturing process same. This is the things involved. First metal powder, then lasers, and what are the processes, adding the layer by layer, then polycrystalline alloy used, another materials will be involved. Then finally we are making the coating blade. Then we are curing the process and committed. Manufactured by high performance turbine blade components produced by using additive manufacturing technology. These are the things. Design, first thing is design by using CAD software, then verifying by using simulations, then we are using slicing software where you can do it to generate G codes, and layer printing, layer by layer deposition process, and finishing as a supporting structures. In reverse engineering, object, scanning, reprints and CAD model and manufacturing cycle. We have to create in the reverse engineering process. And the reverse engineering we are using 3D scanning and CAD model. 3D scanning, alignment of scanning, merging of faces and complex products. Meshing creation, surface modification, smoothing and enhancing, we have to use CAD model also. In the process of stereolithography, SLA, is a file format widely used for 3D printing and computer aided designs applications. It describes the surface geometry of a 3D object using triangular faces. The normal face is a neutral, and we will create the 3D pictures. As a definitions, the working principle of SLA is refers by using 3D printing. We are using UV light, ultraviolet light, and using STL formats. SLA 3D printing process requires stereolithography is a high resolution 3D object we can able to make. In this, we have used laser scanning methods. Lasers, SLA 3D printers or UV lasers are used. UV light projectors to scan the project lights on the surface of the resins. Laser intensity and movement of controlled by 3D models, and polymerization is a technique where laser strikes the photopolymer resins. It causes the resin molecule to react and solidify the forming whole layer of the objects. Layer traces the precise geometry of the first layer based on the 3D size models. This is the diagram. 3D printing diagram in SLA, stereolithography, laser source and XY scanning motors, elevators. This is the resin tank. UV curable resins and cubed layers, layer by layer, build the platforms. And next thing is solid foil polymerizations. Solid foil polymerizations. In this additive manufacturing technology, the solid foil polymerization refers to a technique that involves the use of thin polymeric foils as the material's feedstock, which undergoes the polymerization process to form a solid layer by layer. The method is primarily used for 3D printing, where the foils are either by pre-polymerized or undergo polymerizations during the printing process. The working principle of solid foil polymerization in additive manufacturing combines several techniques in materials science and technology, which along with the AM technology. This is a diagram. Residue take up a road, platform and restructured table, block with embedded objects, film strips, raw material, laces, build tilted mirror focus and burning point, and you have to complete the process. And layer bonding, we are layer materials, layer fusions in traditional 3D printing methods, the newly deposited material layer by layer. In solid foil polymerization, the polymers layer due to the foil exposes the design to bond seamlessly with the layer body. It creates a continuous stable final structures. And next thing is laminated object manufacturing. Laminated object manufacturing is one of the additive manufacturing technology that creates a parts layer by layers, typically from a sheet materials. It was developed in the early 1990s. It's often considered as one of the oldest method in 3D printing. Laminated object manufacturing. LOM is also known as laminated object fabrications. The basic principle of laminating we will see involved in the following steps. In this we are using the adhesions of layers. After each layer is cut, the sheet is bonded in the previous layers. Below it is using heat and process. Sometimes it is using adhesives. Adhesives used can be either thermoplastic materials or that melt certified upon the cooling layers, separate layer by glue applied by before lamination process. Next we are going to see this in this LOM. You have to use this concentration of rollers and laser unit, the printed layers and moving platforms, the preform supply we have involved, and waste preform take up, and the printed layer and concentration layer moving platform preform supplies is used. And next technique is adhesive bondings. In adhesive bondings, it refers to the process of joining materials together using adhesives rather than mechanical fastening or welding. This technique is increasing use in 3D printing, so to bond the layers to attach the components of 3D printing. This overview we can see in these pictures. And bond formations, curing and setting techniques is adhesives applied is must typically undergo a curing process, setting process to form a strong bond. This could be a chemical cure, epoxy adhesives, and curing process is thermoset adhesives, and UV cure process are involved. This curing process hardens the adhesives and create a solid bond between the materials. In this application of adhesive bonding is the bonding of dissimilar materials, reinforced structures and reinforcement assemblies. In this post printing also we have done in this laser bonding process. And next process is beam deposition process. Beam deposition is an IM process, refers to a process where materials is deposited layer by layer by using energy beams to melt and fuse the materials. Application of advanced synthesis, aerospace, medical, dental and aerospace, and tooling and repair and beam deposition process involved. And direct energy deposition process consists nozzle and Texas norm melted deposit with the layer into nozzle, and wire and powder is formed. Many things involved. This is a laser beam and melted in the substrate, and finally product will be produced. The printing process manufacturing based on the concept of building upon a layer. Additive manufacturing process, layer by layer depositions, slice data, adding by layers. There are several techniques involved: FDM, SLA, SLS, direct energy deposition process. These are things involved. 3-dimensional models and pre-processing, generate STL file, and leveling and prototyping how layer level formations, informations, layer processing and bonding and layer by layer, and post treatments, remove the support, clean the surface, and post cleaning, and finally to produce the model. Next things involves droplet formation technologies. AM is one of the techniques. Droplet formation technologies, That involves controlling the deposition of tiny drops and bead materials built up layer by layer in the 3D objects. This is the diagram. Pneumatic based on in the demand liquid material jetting techniques. These are things we can use in the droplet techniques. For example, furnace golden metals, then low oxygen substrate and create the droplet formation technologies. In this material depositions, in the first depositions on a build surface, material can be liquid, semi-liquid and powder. In this droplet based AM, the material is typically deposited in discrete controlled droplets rather than as a continuous streams. Types of material and dispensing mechanisms. Nozzles and printing head is used to control the volume and droplet ejection, such as pressure driven and thermoplastic materials. And droplet control. Controlling size, velocity, position and each droplet is vital. Droplets control include thermal control, elastic control, micro wall and piezoelectric control, and piezoelectric actually should be used. These are the very droplet control techniques. And next we are going to see this about the technique is bio-extrusions. Bio-extrusion is an additive manufacturing process referred to as a bioprinting, refers to the use of bio-inks, biomaterials to fabricate the three-dimensional structures such as tissue, scaffolds, organs and other biological components. The process of combines the principle of conventional fused deposition modeling in biomaterials to prevent living cells and biologically compatible materials. These are the techniques. This is the extrusion of bio-ink. Extruder printing at specialist nozzles to extrude the bio-ink. The nozzle is typically heated and cooled depending on the material properties. Bio-ink is pushed through the nozzles and pneumatic systems and driven the system and piston driven system control the extrusion speed and process. This extrusion process must be carefully controlled to ensure the bio-ink is deposited in the continuous manners. These are the involved spools, driving wheels, materials, heaters and nozzles. This is a various diagram. First one is filament based, and second is plunger and strings based, and third one is screw based extrusions. These are things of the technology involved to make a extrusion of bio inks. And application of bio inks is tissue engineering, 3D tissue scaffolds to regenerate the repair damaged tissues and skin, bone, cartilage, and organ fabrication, development of functions like structures which could be eventually used in the transplant medicines, drug testings and wound healing. These are things involved. And liquid thermal polymerizations. The working principle of liquid thermal polymerization in additive manufacturing focus on converting a liquid polymer resins into a solid structure using heat. This process is integral and various resins based on 3D printing technology, SLA, digital light processing and DR.P. Components involved, monomers and 3D printing technology involved, undergoes the polymerization techniques, 3 polymerization initiators and polymerization process where breaking down the structures and generating the reactive species and triggering the bonding of monomers and heat sources should be used. Application of thermal polymerization is 3D printings. Thermal polymerization is only used in resin based 3D printing technology such as stereolithography, DLP, polyjet to convert the liquid resins into solid objects. Post curing with heat often enhance the material product and enhance the properties. The resins used for thermal polymerization can range from standard rigid plastics to more specialized materials like flexible resins, biodegradable resins you can use used in dentals and medical applications, and high strength resins for industrial uses. For example, is raw materials, modeling parameters involved. This is polymer, liquid resins and process material sintering and curing final parts are developed. In this process, photopolymers, liquids and UV light scanning system and building the directions recoding system will be developed. In this process, exposures and peeling and weighting and leveling systems should be completed. Thank you viewers, thank you students, and we have seen this good technology of additive manufacturing process.